All right, let's go ahead and get started. Good morning and welcome to another AMUG presentation. I'm your host, Daniel Bodale with the Environmental Finance Center at WSU. Um, Today's presenter is Sarah Miller. She's with KMU, and today she's going to be talking about asset management from an operator's perspective. In it, she will contrast incidents from different systems with varying degrees of asset management implementation. Case studies will vary from how a system with a robust asset management program was able to stay in compliance with state regulatory requirements to a system that had costs increase significantly due to its lack of preparedness and an adequate asset management plan. The presentation will emphasize the importance of pre-planning, preparedness, and understanding the status and criticality of your assets. So without further ado, I will kick it over to Sarah Miller.
Thank you, Daniel. I'm assuming everyone can hear me okay. I'm kind of loud, so adjust your volume accordingly. I am a proud Gen Xer, which, a few years ago, we were all still hiding. So I found the water and wastewater industry by accident. I had been in a printing job for 17 years, and they decided to close it down. It was probably the best thing that ever happened to me. I love this industry. I had no clue that I would, but I do. I am a water and wastewater operator level 4, which is the highest you can have in Kansas. I am a distributions and collections level 2. That is a national certification, and then also ASSE backflow prevention certified, which just so I can throw in a shameless plug, when I leave or when this is over today, I am actually going to go and buy the parts for my wet lab because we're starting a backflow prevention class. So we're really excited about that. But I love what I do, and I do this for the operators. I'm going to always have their backs unless they're doing something that's against regulations. So remember that when I talk, because normally I'm talking to operators. I really do try to tailor what I say to who I'm saying it to. So for this class, or workshop, I assumed that you all already knew about asset management. So I'm not going to talk too much about, the different sections of that. But for our purposes for this discussion, we are going to talk about community water systems. That is every public as well as privately owned water system in the nation that has at least 25 year-round residential customers or 15 year-round service connections. The reason that is important is because there are a lot more than just however many cities we have, besides being cities, rural water districts. You can also have schools, churches, campgrounds, parks. So any system that provides water to the public, the reason it's important is because it has to chlorinate. And the reason that we chlorinate is because it works. It keeps people from dying. 20, 24, 26, I'm not sure what exactly where that number is, but that's too many people dying from typhoid fever. And now it's 0 because of chlorination. We're also going to just assume that an asset is any building, tool, piece, or piece of equipment, pipe, or machinery used in operation of treating and delivering safe, clean water. I have 4 examples later, and some are wastewater, some are water. It doesn't matter. We're going to treat them all as things that we need to fix. Excuse me. Another thing about being pipe, I think a lot of times our councils and governing bodies forget how much they have invested in water and wastewater simply because they're large, expensive, long-lived pieces that are usually buried underground. But if you think about the hurricanes that happened, places that never expected had their their distribution or collection systems damaged severely enough that it was a lot to reinvest in them. And that's since the financial aspect of this, that's why I mention it. Asset management is that planning process that ensures the most value from each asset and have the financial resources to rehabilitate and replace them when necessary. If we cannot replace broken things, we can have the state tell us we're not allowed to send water out. If you lose pressure, you don't just get to turn it back on. There are many regulations that we have to abide by, and they'll be part of this. Asset inventory is a way to record and monitor the current state of a system's assets. If you have anyone tell you an inventory, oh, it's too much, I don't even know where to start. Well, you have to start somewhere. And if you don't know what you have, how are you going to know what you're in charge of and what you're responsible for? And the system that I worked for did this. We had an inventory, but it wasn't anything other than what was in the mechanic's head. So it's very important that you do this. Don't look at it as like, oh, so much, start with one thing, start with pumps. I was lucky. I only had to do what was in the office building, but it was still significant. Everything that has a serial number, and don't get bogged down on the silly parts like pens. Just you have, office supplies. The reason that we want this asset inventory, most of those programs that you can get will have a risk mitigation. So if you can put in the maintenance and you get a PO, hey, at the end of this month, you've got to change the grease and the bearings of pump 2. So doing maintenance, repair, rehabilitate, may be able to not have to replace something. And that's what we're trying to do. We're trying to utilize these resources to get that life out of them. And I'm going to tell you, even if something has a 20 or 30 year life, we still don't think it's enough. You are always going to have someone tell you, oh, well, that project was $2 million. It should last forever. It's not going to. I have seen some really sad plants that, it was paid for once and people think that's good enough. It's not. We've got to keep them up so that we can, keep meeting all those requirements from our regulators. So the asset's going to go through 5 major stages: planning, acquisition, utilization, maintenance, and disposal. We're going to focus mostly on utilization and maintenance because that's what an operator does. One of the things that when I did this presentation, I assumed you all knew asset management, but I assumed you didn't necessarily know water and wastewater. So I'm going to apologize if I either talk way over you or talk down to you. It's not my intention. But one of the things that we're currently doing is doing an asset management can work revamp. And I mention it because I'm the operator in the group. And so I'm kind of funny because I'm like, yeah, we need it. Let's just do it. What's the question? But sometimes you have to convince your board or council. Sorry, I just lost my place. Give me just a moment. Okay, so for asset management, having the part on the shelf versus ordering the part is a big time frame consideration, especially ever since COVID happened. Being told a wait time is several months is pretty much the norm. So you have to have it if it is vital. We also have a lot of workarounds. One of the examples we're going to talk about had to figure out how to get air into a neglected oxidation ditch. Turnover, complaints, and customer service. Everyone is having turnover and employee retention issues. Sometimes part of these problems are because you have new people coming in. They may not know what you have, what you don't have. If you even have a CIP program to replace some of those capital items. Anytime that you have a problem that you cannot fix immediately, you can also end up with complaints about your customer service. One of the things that we like to say in water and wastewater is we're never going to be at the front of the parade with the police and the firemen. We're going to probably be at the back of the parade cleaning up because nobody worries about us until they turn on they turn on their faucet and nothing comes out, or they flush their toilet and it doesn't go. So these are just things that as operators we know, and we're going to hopefully give you a little bit of ways to talk your council or board into making sure you have these things. It is very hard to have all that money tied up in your inventory, but wouldn't it be harder if you couldn't supply water to your entire city because you don't have a part, or you have to damage several downstream items because you have to let something go through that you really shouldn't be? So let's get into example one. This is an activated sludge plant. And I will tell you, it does still surprise me how many times I will be in a wastewater class and I'll say, what kind of plant do you have? And when I ask that, I mean, is it activated sludge? Is it a lagoon? Is it an SBR? Is it an oxidation ditch? And just because it's activated sludge, there's several configurations of that. But they'll say a sewer plant. And it's like, is that really what you thought we meant? This is an activated sludge plant. The tank should have been mixing, but the blanket was settling. So someone goes up to the tank and they're running a sample. They're expecting to see a nice mixing, but it's not happening. This tank had two motive pumps, and they knew that one was failing. They weren't quite sure if it was totally out, but the tank was still moving. The contents of the tank were still being mixed. So when the operator went up there this particular day and they saw no movement, they saw settling. If you know what happens in an activated sludge plant, once that is no longer being mixed or aerated, it should immediately begin to separate from liquids and solids. We have to separate the liquid so that we can return that water back into the environment. This is what mixing without aeration should look like in a tank. So just like he said, no air. Now these tanks, if you look right here, you can see that there is some mixing in this tank on the left, and then on the right, there is probably mixing as well as air in that tank. Most blowers are going to be powerful enough to do the mixing by themselves. However, one of the things that we are exploring currently in wastewater treatment is not leaving the air on, because one, it's the biggest energy consumer. It's why wastewater plants use so much electricity. But if you have to have the air on to mix, that's not necessarily the ideal situation. It can be done, but it's going to increase cost. The reason that this is important is really for wastewater treatment, you only need two things. You need air and you need time. Now, activated sludge, we have discovered we can speed the time part up by having a larger bug population in our tank, because the bugs are what take care of all of the treatment. So when you start with a larger population, they're going to be able to consume more food in a smaller time frame. So to not have any mixing in a tank means that the food and the bugs are not coming into contact well with one another. This was probably, let's just say, between 10 and noon in the morning. So the operator waits for the air to come on, pulls the sample they needed, goes back into the office and tells the mechanic, hey, tomorrow we're replacing the motive pump. Now, part that I didn't tell you is that this plant has a new manager who doesn't really understand how they do things. And he gets a little worried because he's not 100% sure that they should take um, the plant down. Well, the plant's not going to go down, but take the tank down to replace that motive pump. So after lots of explaining on how important it is, they convinced the manager that, yeah, it needs to be done. So because they have they have about half a day to set it up and then come in the next morning, get it done. The motive pump, they keep this tank has 2 motive pumps in it. They keep a brand new one in stock as well as a rebuilt one. Now they know that probably both the pumps are bad, but they know that one is much worse than the other. So they're going to take the one that they know is absolutely failed out first. They get it all set up. The next morning, they come in, they replace it. Everything goes great. Put it down, turn it back on, and the pump is running. The tank is mixing. So this is an example that when you have the items in stock and you know it's failed, you can have that turned around very quickly. Yeah, again, replace the next day, kept the plant from being in violation. So one of the things I want to say about the new person at this plant, the plant that they came from had sensors, and the plant that they went to didn't have as many sensors. One of the questions he asked was, how do you know when to waste or how much to waste? Well, I think that this plant was very, very fortunate because they were forced to know their plant because they didn't have sensors. Or they couldn't, they knew that if somebody didn't clean a sensor, it wasn't going to read as well. A lot of plants or lagoons or systems do not have any sensors. Some don't even have DO control, which is a pretty vital part of wastewater treatment. And if they don't have something as simple as a DO meter, which is dissolved oxygen, their system's not going to buy them other things to test. So you have to be able to, with what you have, know how to just figure out where the solids are in your system, where you need to move them to, how much you have to remove to keep your plant running. So it is hard. People who do this well, you should definitely tell them thank you, because wastewater treatment is so vital to separating the water back out and putting it back into the environment. Example 2. This is a system that has that in 2007 replaced 9 miles of a gravity-fed line. They started beginning to get breaks roughly 5 to 6 years later. Oh, I might have put these dates wrong. It was basically, let's just say it was 6 years, and I have my dates wrong. These are 20 feet, 20 feet sections, 20-foot sections, and they are cracking along the bottom. It's an incredibly weird break. When they dig them up, they're not finding any bedding left, even though there was plenty of bedding put down. They've had them tested by different labs. They're saying that the pipe is fine, but the pipe, there's something wrong. No one can figure it out. When they put a saddle tap on, and they had a plumbing company do this. They put the saddle tap on. They went in to put the tap, and the pipe cracked, and they looked at them and they're like, this isn't this, we've never seen this happen. So there's something very weird wrong. There's also a hospital on this line that does dialysis, and when they have a water break, they have to stop the dialysis because there's only a 15-minute window to keep it going. So we have to remember that sometimes breaks are only in the cold, which is bad enough, but sometimes they're also in the water and nice and wet. When these lines break, they are replacing the entire 20-foot section. They've done this, unfortunately, so many times, they're kind of experts at it. The great thing about their administrator is that they are very well aware of the stress on the employees, and they're being proactive. One of the things that mutual aid can do is send like electric power crews to places where there's been bad storms, but mutual aid can also help you just get employees for a short time while you're dealing with something out of the ordinary. For example, and this is pretty well known, so I don't feel like I'm breaking a confidence, Arc City got cyber hacked and they had to run their plant on hand. And so they called up, they got mutual aid, and people would go and work with a person from Arc City so that the other people could have time off. And that is a great thing. And we have to also remember, if you, I don't want to say abuse your employees, but they can tell when you are authentic. And so I think it's very great that this city is making sure that they don't overwork their employees through these breaks. They know that there's going to be another break, so they immediately, when the break's done, they replace their inventory. Their water budget is blown. I mean, these are ridiculous breaks that are just, but it's either fix it or your town has no water. So they know they're going to break. Now they are working on solutions, and I will tell you to definitely be your own champion. If you just think you're going to get an engineering firm come in and you can sit back and they'll take care of it, that's not what this is about. This is your system and your problem. So be in there and make sure that you are helping, because it's kind of like your children. Nobody cares about the stories of your children as much as you do, or seeing pictures. You advocate for your city, schedule the meetings, get people in there. Whatever resources that they're offering, if they work for you, take that. Step up and lead. When you are actively showing your employees that you are trying to solve this problem because you know how much of a problem it is, they know that you're not just like, well, I get to stay in the office while you guys go out and dig the hole. Okay, example 3. This is a picture of an oxidation ditch, and this is a rotor. How it works is it revolves, and as this is a clean one, as these little I'm not sure what those little spiky things, the name escapes me at the moment, but as those go around, the solids that are on them come up and get air, then they bring the air back into the mass of the wastewater. So this accomplishes mixing as well as aerating. They can be really big. They're great because you can have different zones in them. You can see that these are covered. This is probably a colder environment. So they can be covered. It really doesn't matter as long as you are getting that air transfer into the wastewater as well as moving it to get it to the new food source. So this system has had many administrators. And they have an oxidation ditch that was not really well maintained, and the rotors no longer rotated. So they got these things from called oxigators, and they are from North Carolina. Now, I don't know about anyone else, but my plant, we just knew that if we had two things that you replaced simultaneously or installed simultaneously, they're going to fail simultaneously within a few months. So this system, one of them, I'm not sure if it failed or they just sent it to North Carolina for its regular service. Doesn't matter. One was in North Carolina being serviced. So there's one taking care of the oxidation ditch. And guess what? It fails as well. So one of the previous administrators had had the operator find out if they could order, this was before they failed, if they could order another oxigator. And the answer was yes, because most likely anybody's going to sell you anything. Of course you can order another one. Well, their answer was that that was the redundancy, being able to order another one. The problem is, I forgot to say, okay. And so when only one fails, you might say, well, what's the big deal? Here's an oxidation ditch that's only doing one. And that's perfectly fine. It may be that they don't have a high enough flow, and they don't need to remove any extra ammonia. Not sure. It may just be that they cycle them on and off. However, going back to our oxigators, so those failed at the same time. And by the way, this was not the plant that I'm talking about. It was just one that had one rotor going so you could see it. Okay, so both of these oxigators that can only be serviced and fixed in North Carolina both failed at the same time. And if you know much about wastewater treatment, once you lose air, you're not going to meet your permit because air is vital. Now, I'm not saying that this is the plant because I don't really think it is. It's not. However, it does look like a system that had to do something different, because if you look at this swirl pattern here, it looks like it's going all the way around. It doesn't really look even, which is if an engineer had designed it, it would be even. They kind of like that. So this may be a system that had to figure something out. Now, the problem when you use, like, let's say an air compressor to put air into your wastewater, you're not going to have the diffusion and the smaller bubbles that help with that gas transfer. Having bubbles in the water is not really the only thing you're doing. You actually need that oxygen to dissolve into the wastewater. It is what the nitrifiers that remove ammonia, it's what they have to live. So when you have let items go so bad that they no longer even work, that's a failure on your administration part. If they were aware of it and they wouldn't let you repair it, that's a failure. Something that a lot of I'm just going to say decision makers don't seem to understand is that we're doing miraculous things out here with broken down, raggedy equipment because nobody is getting, nobody's supporting the new stuff. They don't want to pay for it. They don't think it's necessary. There are several things that I'll tell you aren't necessary, but being able to put oxygen into your tank is absolutely necessary. The oxigators were fine. If the system is staying in compliance, there's not really a problem. But I would absolutely tell you, if you have to send it to a different state, you need to have at least one, if not two, on the shelf or something else as a backup. Maybe you have a floating aerator that, you put out in your pond in the summer. It doesn't matter. Try to find something, get oxygen in that system, and don't go out of compliance. All right, the fourth example. So wastewater is into several sections. We have primary, and in primary, we remove things like trash, large wipes, I guess will be the thing, and grit. So grit is going to be sand, gravel, eggshell, bone chips, seeds, anything that is not going to break down naturally, that it can be worn away, but it can't really break down by bacteria. So what we want to do is take it out of the wastewater so it doesn't take up space that we want for treatment. This is just kinds of shows your primary treatment is going to be any kind of screening, bar screen. Comminutor just grinds it up so that it's smaller and can get out. The grit chamber is going to let any heavy things settle. We're sending organics through to the next treatment. And it doesn't have to be a clarifier. A lot of times things go straight into an aeration tank now. But then all of that's going to be secondary treatment. And that's just to kind of put that in your mind if you're not aware of it. So we have a system that had a grit pump failure. And I think this was 9 months, but I wasn't 100%. So I put 6 months to get a new one. You have grit coming into your plant every day. I will tell you on the grit train from the plant I came from, we could see pieces of metal. Of course, no one would ever claim it, but there were some metal shops in the area. We would have compliance go over there and say, "Hey, we're getting metal in our grit works. Are you guys sending anything?" "Oh, no, it was never them." But magically, it would stop after that. So I don't know if it was someone just sweeping it into the drain because that was easier. It doesn't matter. You get a lot of stuff out with grit removal. If you don't remove it, it's going to damage your downstream equipment. It can wear on your pumps. All of that grit hitting it can cause wear. The actual grit itself can take up capacity, not only in your pipes, but in your tanks. And it's abrasive. It can wear down parts. So the main reason that grit is one of the very first things that most plants remove is because of how damaging it can be to downstream equipment. This is a system that had a grit problem, and they knew it, but they just kind of ignored it, and they let it build up in this tank, and they let it build up to the point where they weren't really getting any treatment because there was so much grit in there. You can see how tall these piles of grit are. That should never happen, ever, ever. And you have to remember this is waste water grit. So it was in sludge, so it doesn't smell good. It probably is full of pathogens and who knows what. So they have to be suited up in all that protective gear to remove this grit. This is an impeller. You can see the wearing right here from having sand and grit go through it. Same thing here. And when you start wearing on the shape of the impeller and eating those up, you're not going to be able to get the same amount of movement from your pump. This is cavitation. So what this is when you get too much air mixed with your water, and I don't mean dissolved oxygen. I'm talking like actual air bubbles, because maybe you're just pumping so fast it's sucking air. What those air bubbles will do, they will land on your impeller and then they will explode and it cavitates and basically starts pitting your impeller. Problems that grit can cause downstream is destroying your equipment. Grit is heavier than organic solids, so they will cause significant damage to pumps, pipes, and other equipment if you don't get rid of that early in the treatment process. Clogging. I was actually at a plant a couple of weeks ago, and they were noticing that their lift station was starting to fill up, and this is the lift station at the plant, the final one. It was starting to fill up and bypass treatment, and they couldn't figure out why. So they start, seeing, okay, well, is there something in there? There was grit piled up in their influent channel, about probably just 6 inches underneath the water level. So they had so much grit in there. If it got into their tank, it's filling up, taking up space in there. And if you don't have good mixers and aerators, that grit can stay at the bottom a long time. Downstream processes, again, anything that when you take grit out early, next treatment process is going to be less treatment because you're removing that from the grit from out of there. It doesn't have to, so it will make the following processes more effective. So our operator's perspective. The main thing that the operator needs to do incredibly well is communicate with their board, their manager, their council, whatever it is. They have got to get the people with the purse strings and decision-making ability to understand what they need and in the future. Because if the people who set your rates don't know what the needs of your system are, why are they setting the rates? You should be able, your rate should cover your current needs as well as your future needs. If you know that you have an upgrade coming up, maybe you have to charge a $2 upgrade fee, and that goes into a special account and from off everybody's bill, and that funds your future build. So the reason that I included this part is because I think a lot of times, maybe not as much anymore, but I remember elected officials, well, I'm going to get our water rates lowered. Anyone who tells me that water should be free or water is too expensive, I invite them to go drink out of the river for a week and then come back and talk to us, if they can. We pollute everything. That is humans' way. So we have to treat that water. And if it is surface water, we have to treat it even more. There's a lot of treatment that goes into surface water because not only is it full of pathogens, it's also got lots of just dirt and crud in it. And a lot of times I will hear, well, we haven't raised our rates in 10 years. Why? Everything else has went up. And something that I'm not sure that it's an actual rule or required, but it's being looked at. If you apply for an SRF, and I think even some grants now, they want to see a rate review, or that you've done one. They want to see that what you are bringing in is going to cover the cost of your facility. So if you, and I like to use small numbers because my brain is tired and it has too much in it. So if you are bringing in $1 million, but your system's needs $2 million, you've got a big problem. You are running a deficit. Your rates absolutely need to go up. Another thing that I'll tell you, I think that people are starting to look for different ways to get these fees. We had a gentleman from Colorado giving us a talk about their reuse, and one of the things they were talking about was, okay, this is something, this how they're funded, and one of them was their tap fee for a new service. And the room's kind of like, okay, well, that's not much. And he goes, well, let me look up what it is. I I'll be honest, we didn't tap lines, so I'm not sure what a normal cost is. I don't know, 500, 1,000. I truly no idea. But I know that in Kansas, we don't charge what they were, and this was Castle Rock, Colorado. They charge $48,000 per tap. Now, it doesn't cost that much to do it, but if that can go into your future needs, capital improvement, um, emergency fund when stuff explodes, that's where it needs to go. And let me tell you, the whole room absolutely shut down after he said 48,000. That was the only thing that anyone could talk about or think about. Okay, so when you ask for something that is vital to treatment, like I'm going to go back to the oxigators. So when the second one failed, and I'm going to call him Bob, and Bob calls up and says, "Hey, we just lost the second oxigator, and we have no oxygen. So, um, what are we doing?" I guarantee that the administrator doesn't know. The administrator doesn't understand what a violation will mean. And if you don't understand what a violation will mean, the first one is not that big a deal because KDHE understands stuff happens. So if you say, oh, hey, we came in and the blower failed overnight, and of course it was the day we pulled samples because it's always testing day, whatever it is, document that. Tell KDHE why you fail. They're not going to get worried until you fail several and you keep failing several. And then they'll put you under a consent order, which is a legal document that says you are not treating the water to the standard it is required. So you can either fix it and they'll tell you how. They'll say, we're going to make you do this treatment, or they can say we're going to pull your permit and you'll have to have someone else do it for you. So anytime that you go and say, hey, let's pretend we were Flint, Michigan. Hey, we really need to put some corrosion inhibitor in this water. No, you don't. You better believe that if it was Sarah's writing down, Bob Johnson at 123 Main Street at the main headquarters told me, no, we were not adding this, because operators are very proud of their certifications. The tests are hard. They're hard. And so I was very proud when I passed. I'm not going to let someone who got elected, who doesn't really know what they're talking about, mess up my certification. So if you ask for something, I always say send it in an email. Hey, we don't have enough oxygen in the tank. We need another blower. And they tell you, I don't care, fail everything. Save that. KDHE understands it's not you. But sometimes they have to let you get the violations to come and holler at your council. Explain to your council why it's vital. Don't just say, hey, I need $100,000 to buy this really cool meter that does 10 things. They don't care. All they heard was $10,000 and they just say why. If you say, hey, we really need to make sure that we're removing ammonia, and so we need a DO meter to make sure that we're hitting 2.0 DO. If they don't want to do that because it's too expensive, try something like an ammonia strip, a pool ammonia strip or pond ammonia strip. It's a lot cheaper. Is it as accurate? No, but it can tell you, oh yes, I still have a lot of ammonia, or oh look, we're getting all of our ammonia treated. There are cheaper ways to do things. Now, the state isn't going to accept a dip test as anything, but process control wise, we can use it and say, okay, we are removing the ammonia. Okay, this slide, let me get a drink real quick. This slide I included because sometimes, no matter how much you try to explain something, your board, your council doesn't care until someone that they deem worthy tells you. We had a water and a wastewater plant on the same site, and the water plant was built in the 90s. It was built because the two towns wanted softer water, so they softened groundwater, which is perfectly fine to do. But it wasn't surface water, but they did most of the processes of surface water treatment. Now, the PLC is basically a computer that tells things what to do. For example, the input and output. So if your clear well hits a certain level, that means, okay, plant, I'm calling for you to come on. So it sends a signal out to your wells that says, hey, open the valve, start pumping, send me water. They originally had this in a room that was subjected to chlorine. And if you know anything about chlorine, you know that it likes to eat everything. So they changed it. They put it in a different room, but there was still a lot of damage on this PLC. It was 20 some years old. It was obsolete before it was installed. So the first supervisor who was there when I was there asked the board to replace it. No. When I was the interim manager, I asked them to replace it. No. The person who was the manager after asked them to replace it. They said no. And, we clearly explained to them, you cannot even get these parts. These are obsolete parts. They don't even make them. The only way you can get a card for these now is to hope that they have one in their junk drawer. And then you have to drive to Kansas City and get it and hope it works. We had one of our board members tell us that, oh, that's just what computer places do so that you buy the next set. That's not what this was. So after banging our heads against the wall forever, the engineer who was on the team who originally put the PLC in came by and saw it. He was with another company now, and he said to the board, oh my gosh, I can't believe you still have that PLC. Wow, you really need to update that. The next meeting, it got put on the agenda because an engineer told the board, so now it must need it. Trust me when I tell you it needed it way back the first time it was asked. They just chose to not do it. Okay, asset management benefits for water operators. It's going to improve your service reliability. You can minimize the risk of equipment failures and disruptions to water service if you know that you have the parts in stock to make the repair. It will reduce costs. Efficient asset management can lead to lower maintenance and repair costs and better resource utilization. For example, you can decide, hey, we're going to have this pump that can go maybe on three different areas because it's versatile like that. I'm sorry, I skipped one. Enhance operational efficiency. Well-maintained assets and optimized processes are going to give you a more efficient water treatment and distribution. Assets last longer when they're maintained. Better decision making gives operators the data and information they need to make informed decisions about maintenance schedules and resource allocation, and comply with regulations. Operators don't like to get violations. They want to stay in compliance. Challenges that are faced: a lack of resources. You may not have staff. You may not have budget. You may not have testing supplies. Eventually, that's going to catch up. If you can't fix something because you don't have the parts, or maybe they're shoddy parts, you're going to be doing it a lot. obsolete data or parts, if you don't have accurate information, it can change your decision and make it maybe not be the right one you should have made. Lack of training or expertise. I will say that operators, I don't think that they get enough training. I think a great training is to go to another facility and and see something different than their normal every day. Resistance to change. A lot of operators don't like change. I'm one of them, but I also know that we have to do it. So sometimes you're going to get pushback. Deal with that quickly. Don't let the old grizzled man tell you that, hey, we're not going to do this because I've been here 30 years. One of the greatest changes I think you can make is if you do have someone who has ran your plant forever and ever, amen, and they're fixing to retire, I encourage you while they're still there to let someone else actually run the plant and encourage them to make big changes like time, cycle time, something so that they can see what the system is capable of and what happens. Because if you only run it this way because Bob said so, and then Bob leaves, what do we do now? I don't know. Well, why were we doing this? Because Bob said so. You need to understand why things are happening, not because Bob said so. So, in conclusion, operators recognize the importance of asset management. They know that it's going to allow them to keep the water on, reduce costs, and be efficient for their customers. Um, Managing assets can help their operators' communities have a sustainable water future. So, with that, are there any questions? And I'm switching so that I can see the chat if there are any questions.
So if people do have questions and you want to hit the chat button or come off the mute, you can feel free to do that. But for now, let me emphasize a couple of things that, I mean, she made a lot of great points in that. One of the biggest things that we've really been pushing is that assets don't last forever. That may seem like common sense, but I was working with a small community in Northeast Nebraska, and they came to a situation where their wastewater needed their wastewater lagoon had been neglected for 15 years. And this new current board came on, and they realized that no one has been paying attention to this for the last 10, 15 years. And now they're in a difficult position where this town of 150, 200 people is going to have to undertake a $3 million project to address that. And for a population that size, that's huge. Right now, lead times, after COVID, if you haven't done a major project recently, lead times can be unpredictable. So, if you can put parts on the shelf, that may be the way to go. But we have also started doing security training here at the EFC. And one of the things that we want to remind you is that if you store a lot of valuable materials on site, you should have adequate security to protect those assets. I did work for a utility that stored a lot of copper wire on site, and their plant got broken into, in the middle of the night. So that was a huge cost for them, just losing out on those assets. And also phase your replacements. Don't replace everything at the same time so that, everything is getting renewed, in a rolling cycle, rather than replacing all your water meters at the same time, phase them in. It makes it easier to predict spending for years rather than, you're going to have one expensive year and then it's going to be lower for the next couple years. Phase those replacements so that it's more consistent throughout. Collateral damage, again, if you're letting something run to failure and that is damaging parts downstream, that's just more damage, more cost. And just a reminder that, boards and utilities do have a fiduciary duty to make the most use of their ratepayers' money. So, um, me being an ex-regulator, this is kind of one of the things that I really like to harp on as well, just because, um, the cost to fix it is going to remain the same. However, if you do get into regulatory issues, that could potentially, cause fines and fees. If you get put on a compliance schedule, you're going to have to replace it at their schedule, not at your own. So you're going to have to do it much faster than you would have had to have done it if you were planning for that replacement. Costs. Right now with the trade wars, costs could go up substantially within the next year, and it might happen very fast. So just keep that in mind when you are budgeting for major projects in the near future. And then also when it comes to life cycle costing, and if you're buying a new asset, where is it coming from? Where is the technician? Where do you have to send it to get service? Do you have to send it back to North Carolina? And what's the turnaround time on that? And then lastly, think about your large industrial or commercial customers. If your water plant goes down or your wastewater treatment goes down, are those customers going to be very happy with you? And what are the potential ramifications of that failure to those customers? um like she was saying, a hospital line, they need water, and they need wastewater as well to move waste away from that site. So just keep that in mind as well. And lastly, like she was saying, thank your operators. I don't think that operators get enough praise. They probably don't get paid enough either. So while I have your ear, I'm going to go ahead and say that. Uh, but if anyone else has any questions, and I don't see any in the chat right now, you feel free to come off mute if you don't have anything to say right now, but you think of something later. Feel free to email me or Sarah. Um, and I hope you got something beneficial from this. I hope this was a good session for you. Thank you all. I think I'm going to go ahead and end this for now. Thank you again. Thank you, Sarah. Thank you, everyone, for attending.
Thank you.